Welcome to my channel. I'm Zhang Xu. Let's look at the problem 30 in Chapter 22. Chapter 22 is about Gaussian's rule. This is a follow-up problems 29, right? In this case, we put a point charge Q at the center of this cavity. And this shell is a non-conducting shell. The charges is uniformly distributed. The inner radius is R1, outer radius is R0. And also the total charge on this shell is Q. Therefore, we can get the charge density on this shell rho as the total charge divided by the volume for this charge, right? So we get the answer look like this one. Now the first part, if we want to find the electric field density smaller than R1, larger than 0, so we can draw a Gaussian surface. Look like this one. Agree? Yes, then we apply Gaussian's law. We can see the electric field density times the Gaussian surface, 4 pi r squared, equal to enclosed charge divided by epsilon naught, right? Then we can write this function E as this one. And then we look at this Gaussian surface. What is the enclosed charge inside this Gaussian surface? Point charge Q, right? So we replace the enclosed charge Q as the point charge Q. We get answer there. The second case is the R is larger than R1, smaller than R0. So it is there, right? Similarly, we can draw a Gaussian surface. Look like this one. Yeah, there. Now you can see this is the electric field density times Gaussian surface equal to enclosed charge divided by epsilon naught. So we write the electric field density as the enclosed charge divided by 4 pi epsilon naught r squared. The only thing we need to find is the enclosed charge. So inside this Gaussian surface, what charge we need to consider? First one, this point charge Q, we write it there. Another one is the charges located on these shells, right? This is use the charge density times these volumes. And then we simplified, get answer look like there. Now you can replace the enclosed charge with these terms. The answer look like this one. The next one is R is larger than R0. So R larger than R0 located as there. Similarly, we draw the Gaussian surface. That is the electric field times the Gaussian surface equal to the enclosed charge divided by epsilon naught. Agree? Then we write the function for E as enclosed charge divided by 4 pi epsilon naught r squared. Now we look at this Gaussian surface. What is the enclosed charge? Point charge Q and the charges on this shell capital Q. So add these two together, we write this as there. And then replace enclosed charge as capital Q plus negative plus the little q. We get final answer there. Thank you.